Hello, my name is Maria Andrei, and I'm a PhD researcher from the University of St. Andrews in Scotland. I'm investigating how we can use immersive technology to concretely visualize the impacts of climate change in order to achieve ecological attitudes and behavior. Climate change refers to long term alterations in the components of the climate, such as precipitation, wind, and temperature. And these can occur naturally from things like solar explosions and volcanic eruptions, or can be impacted by human activity. Climate change has devastating impacts that are only expected to become more profound in the future, such as biodiversity loss, extreme weather events, sea level rise and coastal erosion, and so on. Yet, climate change information is still perceived as abstract because it relates to impacts that are slow, distant from us, and that are in the future. And this phenomenon is called psychological distance from climate change, and it's been shown to hinder ecological behavior. This is because abstract information does not motivate human action. Instead, only concrete information has an influence on human behavior. Research has shown us that by reducing psychological distance from climate change, we can drive pro environmental behavior, and that VR can actually support researchers on this mission through visualization and direct experience. In this way, VR enables people to grasp abstract concepts by making them concrete through immersive experience and visualization, and has been even called the ultimate empathy machine. Although climate VR simulations have been demonstrated to reduce psychological distance from climate change, there are only very few such projects that have been developed, and most of them are inaccessible to the public because they are not available online or they require really expensive hardware in order to engage with them. Therefore, we aim to expand this research through developing our own climate simulations, showing the past, present, and the future of key areas for the climate conversation and making them available online and through exhibitions across our museum network globally. Through our research, it became apparent that there are no climate simulations that show the impact of climate change on Antarctica. Therefore, one of our main use cases is Paradise Harbor in the Antarctic Peninsula, because this is one of the fastest warming regions on the planet. The Antarctic Peninsula also plays a huge role in the global carbon sink and in regulating Earth's climate. Our second main use case is of North Uist, which is an island in Scotland's Outer Hebrides region. This island also provides outstanding national and international value for its ecological sites that are very rare and important for the global carbon sink, such as Maher soil and saline lagoon systems, but it's also one of the main regions where the Gaelic language still survives today. What's more, we aim to show the connection of how meltwater from Antarctica's glaciers and sea ice produces sea level rise on this side of the globe in North Uist in Scotland. Due to climate change, North Uist is expected to experience increased storminess, leading to extreme floods that will isolate the population and hinder their access to fundamental facilities such as health and educational facilities, and it's also estimated to produce a high level of coastal erosion. Here is a snippet of our simulation of Paradise Bay in its present state. It's currently in its early stages of development. And this is our simulation of North Uist, showcasing how the roads would get blocked in the event of an extreme storm. This is some user feedback that we've received on the North Uist simulation in its early stage of development. And further on, we hope to make these simulations much more complex and see how they can impact ecological attitudes and behavior. Thank you.